Hi, this is AK presenting you a free 1-hour video tutorial on MATLAB basics. Welcome to this video course titled MATLAB Basics in 1 hour. My name is AK. I am an aerospace and control systems engineer with several years of experience as a research and development engineer in the industry. MATLAB is a very powerful numerical analysis and mathematical modeling software that's being used by students, researchers, scientists, and engineers in the fields of physical and life sciences. To make full use of this video course, please download the course files from the link given in the show notes below. You don't absolutely need the files to understand the course, but if you download the free course material, you can follow along with me while I'm actually going through the video lectures. And you can make changes to the MATLAB files, experiment, and thus learn better. I recommend it. Unzip the contents to, say, your desktop. And after unzipping, you should see a folder structure that looks like so. I have divided this video course into 7 easy sections. There is a subfolder for each section. The particular subfolder will have all the files that you need for that section. I have tried to introduce MATLAB basics using interesting and practical examples from real-world science and engineering instead of boring, trivial hello world examples. I have also tried to get those example applications from diverse fields such as fighter plane dynamics, satellite failure analysis, rocketry equations, pharmaceutical drug potency analysis, artificial eye modeling, electromagnetic wave propagation from physics, earthquake response of a tall building from civil engineering, predator-prey population modeling from mathematical biology, and modeling the behavior of a stock price movement from financial engineering, and CAT scan image analysis, etc., etc. Let's get started. If you want to open the files for lesson 1, change the folder from MATLAB like so. And here are the files for lesson number 1. Just double click on the first file. Okay, when you fire up MATLAB, the user interface looks like so. The most important panes or the sub windows are the command window here and the editor window here. And this pane, which is the current folder, it is self-explanatory. And the workspace, we will actually talk about it in a bit. And the command history is also self-explanatory. Whatever commands you type here, it actually remembers the commands that you typed in, and you can actually go back and actually execute them by just double-clicking on the commands. All right, so let's first talk about the command window. The command window you can actually use as a very overpriced calculator. Like for example, you can say x1 equals 2. And you can say x2 equals x1 to the power of 3. And a slightly more sophisticated method is you can define, for example, vector 1 equals 1, 2, 3, 4, 5, and vector 2 equals 10, 20, 30, 40, and 50. All right, so you can actually say figure plot V1 versus V2 and grid on. So this is the V1 vector and this is the V2 vector. Okay. One of the most common ways you will probably encounter MATLAB is through the need for plotting data stored in a file. For lesson number 1, imagine your boss asking you to plot the aerodynamic variables of an experimental fighter jet. The test pilot has flown some maneuvers and the flight computer has collected and stored the following variables of interest: time, elevator deflection, forward speed change, and the pitch rate change, And lastly, the pitch angle change. This text file has the data from some experimental flight runs. By the way, you can actually open a .text document in MATLAB. You just double click on it and you just look at it. It looks like there are 6 rows and there are several columns. It actually goes on and on and on. The first row is actually the time vector, and the second row is the elevator deflection in degrees. And the elevator is actually, let me just show you what it is. Okay, so the elevator is this control surface, and it actually goes clockwise and counterclockwise. That's the input to the experiment. And the third row is the speed change in feet per second. And the fourth row is the angle of attack change in degrees. Okay, and the angle of attack is actually defined like this. The angle of attack is the angle between the chord line and the forward velocity vector. And the fifth row is the pitch rate change in degrees per second. The pitch angle, to begin with, is actually defined as the angle between the horizontal line and the chord line. And the pitch rate is the rate of change of this pitch angle. Okay, so this is the pitch rate. And finally, the sixth row is the pitch angle in degrees. Okay, all right, so you have a text file that has these variables of interest. This is the time vector, and this is the input to the experiment, and this is the response of the aircraft. The flight computer actually records all of this. So what you want to do is you just want to write a script that can load this text file and just plot these variables on different figures. So the first thing you want to do is read this text file, and it's a very simple command. Load, and this is the fighter plane data.txt is the name of the file. Okay, also notice that this text file is in the same folder as the script. Okay, this load command, it actually reads a text file and it actually stores it as a matrix, and this D is actually as a matrix. I'd like to show you how. CLC, clear the command line, and clear variables. It actually clears the workspace, and you can actually put a breakpoint by just left clicking on this number line and just say run. All right, so we have run up to this one. Notice there is nothing here on the workspace, and I just step, which is I click on step, and it actually executes this line step, and the text file has been read and it is stored in the variable called D, which is a matrix. Let's actually double click on it. So this is the first line, first row, which is the time vector, and this is the elevator deflection in degrees. This is the speed change in feet per second, and this is the angle of attack change in the degrees, and this is the pitch rate change in degrees per second, and this is the pitch angle change in degrees. Okay, so this has been loaded into the workspace, and what we want to do now is step. It actually creates a figure, and we are saying plot the first row and all the columns against the second row and all the columns. Let me just explain this a little bit. So if you just click on D, this is the time vector, and this is the elevator deflection. So what we want to do is the first row, this is the first row, and these are the columns, 1, 2, 3. So take the first row and all the columns. Okay, that's actually the time vector. That's the x-axis, and the y-axis for this plot should be the second row and all the columns. That's what we mean by this statement. This is the row number, comma. This semicolon means all the columns. So we are taking the first row, all the columns, and this is the x-axis variable, and the y-axis variable is the second row, all the columns. And this dash B means a solid line, give me a blue color. All right. So y limit 10 to 25 is limit the y-axis values to between 0 and 25. And title, X label, and Y label, they are actually self-explanatory. All right. So I'll actually put another. Okay, let me just step through this code. Okay. this is how it actually looks like. Time versus elevated deflection. All right. So in the next set of commands, I'm actually plotting the speed change, and in this block, I'm actually plotting the angle of attack. The code is the same. What has actually changed is x-axis is the time, and y-axis is actually the third row and all the columns, and so on and so forth. Let me just run through it. So just say continue. So this is the pilot input, okay, elevated deflection, and the experiment has been run for 30 seconds, and this is how the speed changes because of this elevated deflection during this 30 seconds test interval. And this is how the angle of attack actually changes, and this is how the pitch rate, remember the pitch rate is the rate of change of the pitch angle, and this is the pitch angle change itself. That's it. If you want to make the plots look a little bit pretty, I have another script here. So what you can do is close all. It actually closes all the plots, and you can say clear variables, and you'll see all of the variables in the workspace. They'll actually be deleted. You can actually run 1 hour MATLAB 01 plot, fighter plane data, professional plots. So in order to run this .math file, you can actually click on this button, or you can say, you can copy and paste this value, the name of the file, and press enter. Okay. As you can see, the plots are professional grade. Now you can publishing quality. Okay. Again, time versus elevated deflection, speed change, angle of attack change, pitch rate change, and pitch angle change. So that's it for the first lesson. I hope you found this video useful. Thank you.